Hi guys, my name's Joe, and today we'll be starting a video series where we're going to be looking at all the different types of series or sequences in maths. So we're going to be looking at the arithmetic series, the geometric series, we're going to look at recurrence relationships and just summations as well. So this is going to be following on from chapter 3 in the Edexcel Year 2 Pure book. So if you're following along with that, it's going to be all about that chapter 3. Right, first things first, we're going to be dealing with the arithmetic series. And I've written a simple definition for you guys on the screen. And what an arithmetic series or sequence is when a sequence increases or decreases by a constant difference. I.e., if I was to give an example, if I say 2, 4, 6, 8, 10. This is an arithmetic series because each step we are increasing by 2, a constant difference of 2. Another example would be minus 10, minus 13, minus 16, minus 19, and so on. And this is also an example of an arithmetic series because we are decreasing by a constant difference of minus 3. So it doesn't matter if we're increasing or decreasing, as long as the difference is constant, then it's known as an arithmetic series. Right, so for this, we can actually determine a series or how to find the nth term of a series. So we write it as un. This just represents the nth term. So n can be any number. It can be the first term or the fifth term or the 10th term. And this is equal to a plus n minus 1 times d. So this is the basic nth term series. So if I was to, first of all, we need to understand what each term means. So a here, this just means the first term. Okay, sometimes you might see as u1, but u1 just represents the first term. And d represents the common difference. So if I was to use the first example here, this 2, 4, 6, 8, 10, our a would be 2, because that's the first term. And our d would also be 2 because we're increasing by a number 2 every single time. So the nth term equation for the first series I wrote here would be a, which is 2 plus n minus 1 times 2. And with this equation, I can actually find any term we want in that series. So we know this is the fifth term is this 10 here, right? u5 is 10. So let's just see if this equation works. So u5 is equal to 2 plus 5 minus 1 times 2. 2 plus 4 times 2, which is 10. So we know this equation is correct. So this actually works for all arithmetic series, and it's the nth term equation, which you should be very, very familiar with. Right, following on from here, we can actually work out the sum. So the sum is represented by Sn. So n once again means the number of terms. So n could be 10, which means the sum of the first 10 numbers or in that series. And this one here is equation n over 2, 2a plus n minus 1 times d. All right, so for the Edexcel curriculum, you actually need to know how to prove this summation equation. So I'm going to write it for you down here. So as we said, the Sn, or the sum equation, is the sum of the first n number of terms. So I can rewrite it as Sn is equal to, the first term would be the u1, right, which is just a. The second term would be a plus the first common difference, so a plus d. The third term would be a plus 2d. And so on and so on and so on. So that would be the first 3 terms. Therefore, the last term, or the second to last term, would be a plus n minus 2d, and the last term would be a plus n minus 1d. So I've just written the summation out because we're going to add up every single one. I'm now going to rewrite it, but rather than from lowest to highest, we're going to write from the highest to lowest. So I'm going to write the first one as a plus n minus 1d plus a plus n minus 2d plus, and so on, and we'll have a plus 2d plus a plus d, and the last one will be just the term a. So I've just written the summation equation out, but just back to front. And what we're going to do now is going to add them together. So we're going to sum them up together. So on the left-hand side, I'm adding Sn plus Sn, meaning that I get 2Sn. And on the right-hand side, if I was to look at these two here, if I was to add them up together, then what do I get is I get 2a plus n minus 1d. If I now add up these two together again, what I get actually is the same thing. I get 2a plus n minus 1d. If I add these last two together, I get the same thing, 2a plus n minus 1d. So in fact, I'll get the same term, the 2a plus n minus 1d, and I will actually get n number of those. I can write it as n times 2a plus n minus 1 times d like this. And now just simply dividing it by 2 because we have 2Sn, we are left with the summation equation. So for the elixir curriculum, as I said earlier, you need to know this proof, so make sure you're very familiar with it and you maybe practice it yourself and see if you can get it yourselves. Right, that's about it for this arithmetic series. So we're going to now look at some more exam type questions. This is so you can apply the theory we just learned. Okay, so let's look at question number 2. So Jill gave money to a charity over a 20-year period, from year 1 to year 20 inclusive. She gave £150 in year 1, £160 in year 2, £170 in year 3, and so on. So that the amounts of money she gave each year form an arithmetic sequence. Find the amount of money she gave in year 10. So they've told us that is an arithmetic sequence, and so therefore we need to work out our a and d, because the nth term equation is a plus n minus 1d. Right, so in year 1 she gave £150. In year 2, U2, she gave £160. So the difference here is adding plus 10. So that's going to be our d. And our a is going to be 150. So our nth term equation will be 150 plus n minus 1 times 10. So we need this because they're asking us how much did she give in year 10. So all we need to do now is plug in n is 10. So U10 will give us 150 plus 10 minus 1 times 10, which is 150 plus 9 times 10, which is equal to £240. So in year 10, she gave £240 to charity. Right. Part B is asking us to calculate the total amount of money she gave in the 20-year period. So the total amount means the sum in 20 years. So therefore, we should use the sum equation. So Sn is equal to n over 2, 2a plus n minus 1d. The a and d is the same values we found in part A, so we can plug that in. So we have Sn is equal to n over 2 times a was 150 plus n minus 1 times d being 10. And now they're asking us how much did she give in the first 20-year period, so therefore n is 20, and we just plug it in. So S20 is equal to 20 divided by 2. In brackets we have 300 plus 19 times 10. This is 10 times 300 plus 190 is 490. So we're going to get £980 in total that she, £4,900 in total that she gave to charity in 20 years. Right, let's look at the next part. So Kevin also gave money to the charity over the same 20-year period. He gave £8 in year 1, and the amount of money he gave each year increased, forming an arithmetic sequence with a common difference of £30. So Kevin's amount given to charity is also an arithmetic series. With the total amount of money that Kevin gave over 20 years was twice the total money given by Jill. Calculate the value of A. So Kevin has his own arithmetic series, so we need to work out his A value for Kevin and the D value for Kevin as well. Luckily, they told us that Kevin's D value is plus 30, and his initial amount was capital A. Now, from here, they said the total amount that Kevin gave over 20 years was twice the total amount that Jill gave. We know that Jill gave a total of, in part B, £4,900. So we need to work out an equation for how much Kevin would give. So working out for Kevin, we can say Sn is equal to n over 2 again, times by 2. His initial amount given was capital A plus n minus 1 times d, and his difference was £30. And so he says in 20 years, same 20 years, we'll plug in n is 20. Like this. And so we're going to have 10, 2a plus 570. And so this is the amount that Kevin gave in 20 years. As you can see, there's a capital A, so we don't know the specific amount. But we do know that he gave twice as much as Jill. So this we can say is equal to 2 times what Jill gave, and Jill gave £4,900. Knowing this, we can actually find the A now, right? So 10 cancel out. We have 980, 2A plus 570. 2A is equal to, this is 410. So his initial amount he gave was £205. So the actual theory of the arithmetic series is not too difficult as long as you know the nth term equation and the summation equation. It's just applying it to certain exam questions. Let's just try one final question. So for question 4, the first term of an arithmetic series is A, the common difference is D. That's just standard, right? The 18th term is 25 and the 21st term is 32.5. Use this information to write down two equations for A and D. So we know that the 18th term, U18, is equal to 25. And we also know that U21 is equal to 32.5. And therefore, the standard nth term equation, remember, was A plus n minus 1D. So this is how we're going to form two equations. So for U18, I can write this 25 is equal to A plus n minus 1. 18 minus 1 is going to give 17D. And same thing for the 21st term. So 32.5 is equal to A plus 20D. This is how we're going to form the two equations. Right, part B. Show that A is negative 7.5 and the value of D, and find the value of D. Right, so we found two equations in part A, right? So what we can do is simply, we can just do simultaneous equations because we have two equations and two unknowns. So I can just subtract it, meaning I get 3D is equal to 7.5, D is 2.5, like this. We need to show that A is negative 7.5, so I can just plug in this D value into either one of these equations, and I should get minus 7.5. So let's just quickly try it. A plus 20 times 2.5 is equal to 32.5. A plus, this is 10, 50 is equal to 32.5. So A is negative 17.5. I think the question is wrong. There should be a negative 17.5 rather than negative 7.5. Right, carrying on. So the sum of the first n terms is 2,750. Show that n is given by this equation. Right, so the sum of n terms, they said there was 2,750. And so they want us to form this equation here. So we can create using the summation equation. So we have n over 2 times by 2a. Our a is 17.5 or minus 17.5 plus n minus 1 times d being 2.5 like this, which we can now rearrange and hopefully we'll get that equation. So we'll have 5,500 is equal to minus 35n plus 2.5n squared minus 2.5n. So we get 2.5n squared minus 37.5n is equal to 5,500. And as if you divide everything by 2.5, then we actually get that equation here. So n squared minus 15n is equal to 55 times 40. So it's just simply plugging into the summation equation. And finally, hence find the value of n. So they've written it out for us to write it like this, but it's now a quadratic equation, right? So n squared minus 15n minus 55 times 40, which we can actually factorize. So we're going to have n minus 55 plus 40, meaning n is negative 40 or 55. Right, important thing to note, n was the number of terms, right? Meaning that we can't actually have a negative n term. So this minus 40 is incorrect, so n is only going to be equal to 55. So this is the arithmetic series. It's just as long as you know the two equations and you know how to prove the summation equation, then it's all a matter of just applying to the exam question. In the next video, we're going to actually be looking at the geometric series, which is a slightly different series. And if you have any questions about this arithmetic series, then leave your comments below and we'll try to get back to you as soon as possible.